I'm gonna record this. All right, so good morning. My name is Dan Steffi. So I'll kind of break down how this will go for not just for today, but for the other Zoom sessions we do throughout the course, and then we'll get started. I like to get started right at 8 o'clock. So it's 8 o'clock now, so we'll go ahead and get started. So I'll do these every other week, and the reason why I'll do them every other week is because that'll be the weeks that you actually have assignments due. So you have assignments due on week 2, 4, 6, and week 8. So what I like to do is hold these sessions and go over information, the material from the class, but also to talk about the assignments, kind of give you some help, give you some hints that'll hopefully help you out. These are, of course, optional. There is no mandatory requirement to be here, but it is to your benefit to kind of hear me talk about the material directly and really to get some assistance with the assignments. The sessions are also being recorded, and I will get those videos posted later today. So, if you come in late or you can't make it, or you just need to review something that I talked about, you'll be able to do so with the videos. All right, so let's go ahead and get started. So really the first 2 weeks of the course was just, talking about Java in general and specifically about Java classes and the different characteristics of a Java class. So let's start off by thinking about, so what is a Java class? Well, a Java class is just a way to represent in code like a real world object or some real world functionality that you want to implement. So, as I go through this and talk about it this morning, I'll be giving kind of a practical example. And the practical example I'm going to build off of is, let's say, a house. A house is a physical real world object. It has characteristics. For example, what color is the door of the house? How many rooms does the house have? How many square feet is the house? Those are kind of characteristics of a house. But also, what are things that you can do with a house? Well, you could buy a house, you could sell a house, you could paint the house, you could open the door to the house, you could vacuum the carpet in the house, things like that. So really, a class is a way to kind of centralize those things that I just talked about, the characteristics of a house and the things that you can do with a house. And of course, we can generalize that to any Java class. Instead of a house, it could be a car. And you would have similar things where you have characteristics of a car and functionality of a car. But for our example, we're going to use a house. So let's make some code that provides the functionality of a house. So you should be able to see my screen here. For my coding, I'm using this IDE. IDE stands for Integrated Development Environment. This is IntelliJ. This is what this one is. Really, you can use whatever IDE that you want to use. You could just use Notepad if you wanted to. That's fine. You can make your code in Notepad. But I like using, this is my personal preference, is using the IntelliJ one because it has a lot of nice features to help you go ahead and compile, and also provides a lot of like automated things to help you complete your code. So that's what this is, but we're just going to be doing the Java code itself. So let's start out by making a new Java class that is a house. So I will just add a new Java file. I'm going to name it house. The name of your file needs to be the same as the name of your class. So as you can see here, I made a new class called house, and it's also in a file called, right here, house.java. The name of the file has to match the name of the class. That's just one of the things about Java. Okay, so let's talk about the characteristics of a house. What are defining characteristics of a house? Well, start off by making a comment. It can have the number of rooms, right? When you see the / right here, it just means it's a comment. It means it's not real code that's actually going to execute. This is really for humans to remember, kind of what's going to be going on. I think I'm kind of frozen. All right, there we go. I'm unfrozen. All right. So a house has, how many rooms does it have? You know, how many square feet does the house have? What else? Number of bathrooms. These are just characteristics of a house. The exterior color, the interior color. All right, and we'll stop there for our example. So these are characteristics of a house. And when you want to put that in a class, you do that with what we call the variables. These are pieces of code that let you store information specific to what your class is. So for a house, we want to have all these characteristics. So we need to have a variable for each one of those. And you got to think about the different types of variables. You have integer variables, which are just their whole numbers. You can have floating point numbers, which are decimal numbers. And you can have strings, which are just text strings, just words. Okay. There are a couple other ones. I'm not going to worry about it too much right now. That's enough to get us through what we're trying to do here. So for number of rooms, would that be an integer, a float, or a string? It would be an integer because you can only have a whole number of rooms. You don't have 1.5 rooms, right? So we'll have an integer and we'll say the number of rooms. So now we have a piece of code that lets us store how many rooms the house has. Let's see, for square feet, let's also make it an integer. Square feet, same thing. For the number of bathrooms, we'll make that one a float. Because if you've ever looked at houses or like listings for houses, you know, they can say 1 bathroom, 2 bathrooms, or 2.5 bathrooms, you know, kind of if it's just a half bath. So we'll make that as a float so that we could have whole numbers, but we can also, it allows us to have half a bath. For the color, we're going to make that a string. And I say that because, you know, it could be red, blue, green, purple, orange, etc., etc., etc. Right. And actually, we have 2 colors. This should be the external color. We'll have another one. It's the internal color. Like I said, the only variables, the only types we're going to be working with this morning are integers, which are whole numbers, float, which are decimal numbers, and strings, which is just text, just words. You can get other variable types and they can get a lot more complicated. We're going to start it off simple this morning. There is ways that you can get a color type of variable, but we're not going to worry. We're not going to get that complicated this morning. We'll just have a string that says what color it is. All right. So that's kind of the description of our house. Okay. Sure, there's a lot more other things for a house, but try to keep it as simple as we can this morning. So that describes our house. Now we need to make functionality for things that we can do with a house. So what are things that we can do with a house? We can open the door. We can close the door. We can vacuum the carpet. We can buy a house. We can sell a house. You know, what else can we do with a house? One more thing. We'll just say clean in general. We can clean the house. Okay. Those are different things that we can do with a house, or things that we can do to a house, actually. So when we talked about the characteristics here, we use variables to represent those, right? When we're talking about the things that we can do with a house or the things that we can do to a house, we have to do those with actual functions. Now, a function is just a sequence of code that actually does what you're trying to do. So, for example, let's make a function that opens the door. Well, to make a function, it looks like this. You have to have its return type. And what I mean by return type is, does the function give you something back, or does it give you nothing back? And we'll kind of see an example of both of those. When I say void, it just means the function doesn't give me anything back. It does some kind of work, but it doesn't give me anything in return. Okay. Now we got to name the function. We're just going to call it open the door. And then you have these parentheses. Inside the parentheses, you have to give it what parameters it needs to know. So what do you need to know to open the door? What does the house need to know? It doesn't need to know anything. And we'll see some examples where you do need to know something. But to open the door, we can just leave it at that. Let's go ahead and make the outlines for the other ones. And then you can see after the parentheses, I have these two brackets. The brackets are where the code starts and the code stops. So in here, we need to code the functionality to open the door, right? So this function, it doesn't open the door yet. In here, we have to put the code to actually do the work to open the door. All right, let's make the other ones. We had a close the door. Very similar, close the door. What else we have? We have vacuum the carpet. In the carpet. Oops, you spell right. Then we have buy, sell, and clean. Let's just make them all void, and we'll change it whenever we see we need to change something. We can buy a house, we can sell a house, and we can clean a house. Okay. So all of these are the different functionalities that we can do with the house. There are probably more, but like I said, we'll keep it kind of minimal this morning. Here my extra spacing. There we go. So now inside of each of these functions, we actually have to do some kind of code, some kind of work to actually open the door or to close the door or to vacuum the carpet. Okay. So for open the door, let's think about this for a second. So when we open or close a door, the house kind of needs to remember, is the door open or is the door closed, right? Well, let's have another variable. Actually, we're going to have this one called Boolean. And it'll be a variable to know if the door is open or closed. So we'll say, is door open? What's the name of that? And as you can see with these variables and these functions, I've kind of given them very descriptive names. That's kind of a key you need to remember is when you're making variables, it needs to be descriptive of what the variable represents. This is going to be some kind of value, but just looking at the name of it, I know that that value is how many bathrooms the house has. Likewise, when I have these functions called, say, close the door, that description is almost enough to make me understand what the function actually does. For example, instead of close the door, if I put xzvb as the name of the function, and Java will accept that, a function name can be whatever you want it to be. But whenever I look at that function name, you can't quite understand what it's actually doing. Sure, we could look at the code inside of here and figure it out, but it's really a lot more useful if we name the function kind of something that represents what it actually does. Okay, so let's start making the code for each of these sections. So for open the door, what should we do? Well, we have a variable here, and it knows if the door is open or not. Is door open? It'll be true if the door is open. It'll be false if the door is closed. So if we're going to open the door, if we're going to do that to the house, let's make our variable true. So now if we execute this code in here, and I'll show you how to do that. But if we execute this function, it's just going to take this variable and make it true. So what does this variable represent? It represents if the door is open or not. So if we call open the door, we're just going to make this variable be true so that the door is open. Likewise, kind of the opposite of that, if we want to close the door to the house, we will just make that variable false. So now we have a variable that represents if the door is open or not. If we call the function open the door, we're just going to make it to be true. And if we run this code, close the door, we're going to make it false. Okay. We'll pause right there for a second for making those functions. We will continue it, but now let's go ahead and do this. Let's use these so that we can see how the variables change. So let's go back to our main function. So remember, we have a house class. We have a class that is house. So let's make a house. And here's how we make a house. We say house, which is the variable name, excuse me, which is the class name. The name of the class is house. We have to give it a name. We'll just call it my house. This is the variable name. And we have to make a new house like this. So when you have this class, this house, you haven't made a house yet. Think of this kind of like a template that describes a house and describes the things you can do with a house, but it hasn't actually made a house yet. Here is how we actually make a house. This is in my main function. This is the function that gets executed whenever you start your program. And in here, in my main function, I have the class name, which is house. I have a variable name, my house, and this can be anything. You know, a variable name can be anything, but let's keep it descriptive, my house. And then we say it equals a new house. So that has now created a new house. So what can we do with it? We can open the door and we can close the door so far, right? If we look back at our house class, we have, these are the things we can do with a house. But so far, the only ones we've made code for is these first two, is open and close the door, right? Really, that's the only thing we can do with the house so far. So let's open and close the door. But first, let's print the house, just so we can see something on the screen. Okay, let's just run this and see what happens. I'm executing it. And here we go. This is the output. This was the output from the print. I know it looks kind of funny and we'll make it look better soon. But what this is saying is whenever we did this system print, the my house, this is what got printed out right here. We'll make it look better, but just for FYI, if you're wondering what this means, is this is the name of the class. You see the house right there. And this is actually the memory address in your computer memory where that class is located at. But let's make it look a little bit better. With our classes here, we can have another method called toString. You can do this with every single Java class. And what the toString method does, whatever you put in here, whatever you return, that's what will be printed out whenever you do this system out.print and you put your class in here. You know, we're doing my house. Whatever you put in here is what will be actually printed. So before we didn't even have this, right? And so by default, it'll print something like this. But let's have it print something different. This is a house. So we'll just return this string. This is a house. So now whenever we print it, it should print out this is a house. Let's run it. And there you go. So now it prints this is a house. So that's an easy way for you to get information about your house. This is a house. Now, just saying this is a house isn't very useful, right? Let's have it print out if the door is open or closed. So we'll say door open, and then we'll do is door open. What I've done here is I made a string that starts out saying door open, and then I'm going to add on to it this variable. And what is the variable? It's a Boolean, meaning it's true or false. And it's really the state of the door. Is the door open? Is it true? Or is the door closed? Is it false? So now let's run this. Now that I've changed this to say if the door is open or closed, let's run it. And right now it says the door open is false. So right now the door is not open on the house. And the reason why it's not is because so far we have not executed these two functions. We haven't done it yet. But for a Boolean value, its initial default value is false. So because we haven't changed it yet, it means it's by default false. And so whenever we call the print my house, and it goes down here to this toString method, this right here is what it's printing. And of course, like I said, by default, the door open is false. So let's do some opening and closing of the door and do some prints to see how it changes things with our class. But we need to discuss one more thing before we get there. And this is covered in your, I think it's the week 2 material, where it starts talking about encapsulation. And what encapsulation means is, what about my class is viewable or is accessible outside of the class? So you can see here, I have these two files. I have my house file, which is the house class itself that we've been building. And I have this main file, which has my main function, my main method. And this is where the code starts getting executed. So these are two separate files, right? So we need to think about what parts of our house can be accessible from outside of the house. And what do I mean by that is, in main, what part of my house can I access? So if I look at house, I have to look for what's called public. There are kind of 3 ways that you can classify the variables, and 3 ways you can classify the functions of your class. And they are public, private, and protected. We're not going to talk about protected too much this morning. We'll actually be doing protected in a few weeks from now. So really, this early in the course, you only really need to worry about public and private. So when something is public, that means that you can access it from outside the class. If something is private, it means that you cannot access it from outside the class. And so let's see about how we designate each of those. So for this open the door function, if we want to be able to access it from outside the class, we need to put public here. Public means that in my main function, which is outside of the class, I can now use that open the door function. Right now, I can't use close the door, and that's because I have not yet marked it public or private, and by default, it will be private if you don't explicitly put it here. So, but if I put private here, I'm explicitly telling it that it cannot be accessed outside the class. So let's see that in action. All right, so we have a public open the door and a private close the door. All right, so let's put some comments. Make our house, print our house. Like I said, those are just some HOU, let's see, there we go. Those are just some comments so we as the programmer can remember what we did. So let's open the door. And here's how we open the door. So we have our variable name. Our variable is my house. And we have this function called open the door. So the way we execute that code is we have my house, then we do dot, open the door. That will open the door of the house. So then let's print the house again. Just copy and paste that. So what are we doing here? We're making my house. We're going to print out my house. We're going to open the door of the house. And then we're going to print out the house again so that we can see it actually did change. So let's run it. And there you go. At first, it says our door open is false. But now our door open is now true. And that's because right here, we just made the house, and by default, the door is closed. Here, we're going to execute that piece of code that opens the door. And now when we print it out again, it tells us that the door is open. It's true. So right here is the key where we do my house dot open the door. Whenever we do this open the door, it executes this code right here, this open the door code in your house class. And whenever we did that, we just said, hey, the door open is going to be true. All right. So that's the public allowed us to access this. Now, let me show you that how the private restricts us from accessing it. Right now, we cannot close the door because it says it's private. If it's private, I can only use it inside of my house class, and I can't use it outside of it. So let me show you when we're going to try to use it. Try to close the door. So if we do my house dot close the door, it's actually going to give me this red squiggly in here because my IDE is smart enough to know that I can't access it because it's private. Even if you're using Notepad or something like that, whenever you go to compile it, you actually get some kind of error. And it tells me that close the door has private access, in the house class. So I'm trying to access something private from outside the class, and that's just not allowed. You can't do that. So let's change this to be public because we do want to be able to close the door. Now let's go back and do it. Let's add in another print so we can see how things change. There we go. So now you can see I don't have the red squiggly, and it will now let me compile it. So we'll compile it and run it. There you go. So the door starts off being false. We open the door and print it. So we get the door is open and it's going to be true. And then we close the door and then print it. And the door open is back to false. So that's how we can use the functions and what those public and private things mean. Now, let's talk about another thing with public and private is when you have variables, there is almost never a good reason to have them public. All of your variables of your class should be private. There's probably a rare exception to where maybe it is accessible or acceptable to make it public, but you should always make your variables private. Like I said, I can't even think of a good reason off the top of my head why they should be public, but you should explicitly mark them private. That way you can't access these variables outside the class. And the reason why you don't want to do that is because, this is kind of the description of the house, right? It's about the internal makeup of what a house is. You really don't want to mess with those outside of the class. There are ways that we can change them, and we'll look at that here in a second. But generally, by default, you want to mark your variables private. And hint, for the assignments that you turn in, all of your class variables should be private. If you mark them public, you'll probably lose a point or two. So how do we manipulate these if they can't be public? Well, we did it right here, right? We had a method, a function here that did let us manipulate those variables, right? So we had a public method called open the door. And when we do that, we change the state of the variable, right? The same thing with close the door, but we haven't directly accessed these private variables. So since this variable is marked private, we can't come back here and do my house. What did I call it? Is door open, right? Equals false. We can't do that. My IDE is smart enough to tell me that it can't do that. But even if we try to compile it and do that, it's going to tell you that you can't access it because it's marked private. And that's a good thing for variables. You don't want to be able to access your variables directly outside of the class. So that's the difference between private and public. Public, it can be accessed outside the class, and private means it cannot. So really, for all of these functions, we want these to be public. Generally, your functions will be public, unless your homework explicitly states to make it private. Then generally your functions will be public, because these functions are how you interact with the house outside of the house. Just like we're interacting with the house by doing open the door and close the door. So those need to be public. Let's fill out the rest of these functions. So to vacuum the carpet, what is the code that we should do to vacuum the carpet? Well, let's add another variable. So just like we had a variable to know if the door was closed or not, let's have a variable to know, is carpet clean, right? Have we vacuumed the carpet or not? So if we vacuum the carpet, then the carpet clean will turn to true. It's now clean carpet, okay? Let's add some more stuff down here to our print that says carpet clean, so that when we print it out, we know if the carpet is clean or not. So all I'm doing here is the same thing, door open plus that variable, but we want to keep adding more information that it can print out. So we add more string to it. The \n just means it's a new line, so it'll print on one line after the other. And then we'll say, is the carpet clean, true or false? Let's run that. Oh, let's make this bigger. So back to our main. So we made the house and we printed it. So right off the bat, the door open is false, the carpet clean is false. Now we're going to open the door and print it. So the door open is true. The carpet clean is still false. We haven't cleaned the carpet yet. And then we close the door and print it. So the door open is back to false, and the carpet clean is still false. We haven't cleaned the carpet yet, right? Now, let's take out some of these extra ones. Open the door, delete those out of here. So let's clean the carpet. Clean the, oops, up here. Clean the carpet. And how do we clean the carpet? We have the house dot clean the carpet. Actually, it's vacuum the carpet, right? That'll clean our carpet. Let's print the house out again so we can make sure it changed. Let's compile it and run it. There you go. It starts out being door closed and carpet is not clean. But now the door is still closed because we took out the part, we deleted the part where we opened the door. But the carpet is now clean. The carpet clean is true. We cleaned the carpet. Right here, it's where we did vacuum the carpet. Okay, that's something else we did to a house. What else can we do with a house? We can buy it, we can sell it, and we can clean the whole thing. Since we already did the vacuum carpet, I'm just going to remove this clean to cut down on the amount of work that we have to do. We already have something here that's kind of vacuuming the carpet and that's cleaning it. All right. So let's talk about buying and selling a house. Actually, let's cut it down one more and just keep it down to buy. You can make as many functions as you want, but to keep our example short, we'll just have the buy function left to do. Okay. So what happens when we buy a house? Well, we have to pay some money, right? How much is the house worth? Well, how much is the house worth? That sounds like another description about the house, right? So let's add another variable here, private, make it a float, value of house, right? Let's take out, we have all these other variables that describe a house. We're not using all of them, so let's just delete the ones that we're not using. Let's change this to color. We will do the color here in a second. So we just deleted some of the extra variables that we weren't actually using for anything. And we haven't used color yet. We will get to color in a minute. We'll do one more with color. So we have this value of the house. Well, let's add that on here to our printout, just like we did with if the carpet is clean. Value of house. Value of house. Let's just print that out so we can see what happened so far. There you go. Right now it says the value of the house is 0. And that's because we haven't changed this value yet. And by default, a float has the value of 0. So here where we're doing this string, building this string, the door open, the carpet clean, and the value of the house. That's exactly what we're getting right here. So the value of house is 0. So when we buy a house, we have to pay some money, right? Sorry, I see a hand raised. Go ahead if you have a question.
Yeah, so I have a quick question, and it may be a little bit too advanced at this point, but when doing number values with float, don't you have to worry about rounding errors? I've had that problem in the past with like money values.
Yes, absolutely. There is it's actually beyond it's more advanced for the entire course, actually, with this being a kind of a mid-level Java course.
Okay.
So yes, what he's referring to is all binary computers. So this isn't just a Java problem, but every computer system has some inaccuracy when you're talking about float numbers. I'll actually post a video on the course announcements later today. It's a great video describing why there are the inaccuracies in floating point numbers, if you're just interested. But there is the possibility that whenever you're working with the floating point numbers for this class, you may get an answer that's really, really close to what you expect, but it's not exactly what you expect. And when I say really close, I mean like 0.000001 difference from what you expect. And so if you start seeing an extremely small difference in the answer that you expect, that's usually because of how binary computers represent floating point numbers, and it's just ever so slightly inaccurate. So I'm not going to dive more into that right now. It is a more advanced topic about why that happens, but I will post a video so you can watch it if you want to learn why.
Okay, thank you.
All right. So for the buy the house, that's going to be determinant on what the value is, right? We're going to pay some money for the house. So we want to set the value of the house to something, right? Because if we bought the house, the value of it is whatever we bought it for, presumably. So what do we change the value of the house to? Well, we could just have some hard-coded number in here. We could say 16.5, right? The little F on there just means that this is a floating point number. Just a little thing about Java. If you don't put the F on there, it complains a little bit. If we put an F there, it just means it's a floating point number. So we could just put this number there, right? And then we're just changing the value of the house to 16.5. So let's run it and see what happens. Well, right now, the value of the house is still 0. And why is the value of the house still 0? Well, we didn't buy the house yet, right? We have this function that lets us buy the house, but we haven't actually called it yet. You know, we made a house and we cleaned the carpet, but we didn't buy it yet. So let's buy the house. Buy the house. So just like we did with the other functions, it's my house dot buy. And then we'll print it out again. So now when we run this, this is before we bought the house. You know, the value was 0 because the default starting value is 0. But now after we bought the house and we printed it, well, the value of the house is now 16.5. Okay. But, you know, we really shouldn't have this set value in here. Why? But, you know, all kinds of houses have all kinds of different values. So we need a way to change this to whatever value we want it to be, how much money we paid for it. Well, here is where you get into the parameters for the function. And what do I mean by parameters? Parameters, they can also be called arguments. So if I say parameters or if I say arguments, it really means the same thing. Inside of this parentheses right here, you put the parameters that the function needs to know to be able to do its work. So inside of here, we can put a float cost of house. So a float is the type, and cost of house is just another variable name. And so this right here is going to be some information that the function needs to know to do its work. So what we can do, we can change the value of the house to the cost of the house. So whenever we call this function, whenever we call the buy function, we need to give it some information. It's expecting you to tell it what the cost of the house was. And then we want to set the value of the house to whatever that cost is. So again, when we call the buy function, we need to give it another piece of information, which is the cost of the house. So if we go back here to our main, and we can see we have the myhouse.buy. My IDE is complaining. It has the little squiggly line in there. Does that make that says you're missing something? But even if you don't use this one, if you try to compile it, it's going to tell you there's a problem here. It's telling you on line 12. So if we look at line 12 here, this is where the problem is. And it's saying that, you know, the house cannot apply to be given title. It says it's requiring a float. It found you have no arguments to it. And there's kind of a reason. I think it's fairly descriptive of what's going on. But we can see here, we're doing the buy function. We're calling buy, but we're missing something. If we go back and look at buy, it's expecting us to give it what the cost of the house is. Here is the arguments. Here is the parameters that you need to give when you call the buy function. So let's go back to buy and let's give it a floating point number. Let's call it 100.1 float. So now it stopped complaining. It will actually compile and execute now. And let's see what it tells us now. So if we run it. So now, after we buy the house, we can now see the value of the house is whatever we bought it for. Let's buy the house a second time. You know, just whatever value that you want to put in there is fine. So we bought the house one time for that amount. Now we're going to buy the house a second time for that amount. Okay, let's run it. And there you can see, there's the house before we do anything. There's the house after we bought it the first time. And you see the value of the house is 100.1 because that's the parameter we gave it. And here we're going to buy it a second time for 56.56 and print it out. And now the value of the house is 56.56. So that's an example of a function with a parameter that you have to give it. And this is completely made up. This is just how we made it for our house example. But this is how you make a function that takes a parameter. And it doesn't have to just be one. You could have basically an unlimited amount of parameters. So if you needed a lot more parameters, that's perfectly fine. You could have them, more of them, string something, int something else, not strong, but string, etc., etc. And you see, I just separate them by commas, and really there's no limit to how many you can have. You can keep going forever, as long as you feel like typing. But you really only want to give it the ones that it needs. But so it does not need all these other variables, all these other parameters. So we just keep it short to only the piece of information that it needs. And when you buy the house, it only needed to know how much did you pay for the house. And then it will change the value of the house to whatever you paid for it. Let's do one more function with a parameter, and we'll have it do with the color. So let's paint that. Let's make a method to paint the house. We'll make it public so that it's accessible from outside the class. We'll make it void, meaning it doesn't return a value. We'll do an example in a minute where it does return a value. Let's name it something. We'll call it paint the house. That's the name of it. And now, as a parameter, we need to tell it what color do we want to paint the house. So when we paint the house, we want to change the color. So we'll just say the color of the house is equal to the new color. What may be a little bit confusing here, I'm sorry I didn't mention this earlier, is where I have this dot. Whenever you do this dot something, you're referring to the variable inside that class. So when I do this dot color, we're talking about this color, the color inside the house. Or this dot is the door open, we're talking about this variable inside the class. So when I do this dot color, I'm talking about this variable inside the class called color. And when I do just the color without the this, that's talking about this variable right here. And if it helps you, you can name this something different. We can just name it C, maybe. And that's fine. The variable name isn't important. It's important that you make it descriptive so you can understand, what it represents. Okay, so we got that. Let's add on here something else to print out. We'll say the color of the house. Color of house. All right. Let's run that. Right now, it says the color of the house is null. Null is just a special Java representation that means nothing. Okay. And why is that? It's because we haven't actually changed the color yet, right? We've made the house, we've bought the house. Let's take away this second by. Let's paint the house. So we have myhouse.paint. And what color do we want to paint it? Let's paint it red. Okay. We have to give it a parameter. Remember, If we don't give it a parameter, then it's going to complain. It's not going to work. And why is that? If we look at our paint the house function, there it is. It is requiring us to give it one value. It needs to be a string, and it's going to be the color you want to paint it. So we need to give it a string of the color we want to paint it. Let's paint it red. Now let's try to run it. There you go. You get the starting values. This is the house after we bought it. And this is the house now. So we bought the house and we painted the house. So the door is still closed. We took out the part where we opened or closed the door, right? There's no open or close here. So the door is closed. The carpet clean is still false because we deleted the part where we vacuumed the carpet. The only thing we have left is buy the house and paint the house. And you can see that is reflected here, where the value of the house is whatever we bought it for. And now the color of the house is red. It changed from null and it changed it to red because we painted it red. Let's paint it one more time. Paint it green, right? Let's save it and run it. And there you see we have here, we had the house color null. That's before we set it. And now the color is red. And now the color is green. So these functions are ways that we're interacting with the house. All right. Last example we're going to do for a function. And then we'll take any questions you may have, and then we'll talk about the homework assignment after that. So one more example. I said I was going to do an example about a function returning a value. Like I said, this void right here, this represents what the function is returning. Meaning, when let's look at this buy for example. When we have this buy, where's it at? Here's this buy. We're just saying myhouse.buy. We're not doing anything with that, with the information, right? We're just saying buy the house. And that's because the return type is void, meaning it does not give you anything in return. It can do some internal work here, and that's the work it's doing, but it doesn't actually return anything back to you. Let's do an example of that. Let's make one more method to compute the tax that you own the house. Let's compute the property tax. Okay, so start off, we'll make it public, meaning we can access it from outside the class. But now we need to think about what it returns. So if we're gonna, let's think logically about this for a second. If we are computing how much tax we owe, what should be the return type of that? What is the value that you're computing? So let's think about kind of the few types we've used so far. So far, we've used a string, a bool, a float. Remember, there's an int that represents whole numbers. But if we're going to compute a tax, that's probably going to be a float. And I say that because, you can have whole dollars and you can have cents, right? So the float is the return type, meaning this function is going to do some kind of work and it's going to return to me a floating point value. We'll see it in action here. Now we have the name of the function. We'll just call it compute tax. And does it need any kind of parameter? We'll see in a second. So how do we compute the tax, right? Just in regular real life, you take the value of something and you multiply it by some kind of tax rate, right? So let's just make a comment here. The tax is the value multiplied by the tax rate, right? So let's make a variable tax. This is going to be the computed value. So we need to take the tax is, so tax is equal to the value. Do we have the value of the house? Well, we actually do. This is the value of the house. Okay, this dot value times, multiplied by the tax rate. Do we have a tax rate yet? We don't have one yet. There's no tax rate variable. We could add one if we wanted to. We're not going to do that though. So we can either make up a tax rate, or let's give it as a parameter, tax rate. So what are we doing so far? So we've made a public method, so it's accessible from outside the class. The float is, what is it going to give back to us? What is it going to return? The name of it is compute tax. These are the parameters that we need to give it in order to do the work. So we need to give it whatever the tax rate is. And this is just a comment saying, how we compute it. The tax is the value multiplied by the tax rate. That's exactly what we got right here. We got a tax variable. It's equal to the value of the house times the tax rate. But now we need to return this. We said we were going to return it, and this is how you do it. You have the Java keyword return, and then this is the value you want to return. We're going to say we're going to return this tax that we computed. Again, the tax is the value of the house times the tax rate, and then we're going to return that tax. Whatever this value ends up being computed as, that's what it returns. So let's see how we use this. So after we print the house, let's print something else. Let's compute the tax. The tax is equal to, let's get rid of some of these other things that we're not using right now. All right, here we go. So we're making our house, then we're going to print it out. Let's get that print. Just cutting it down to the bare bones here. All right, so we're going to make our house. We're going to buy our house. Let's compute the tax. So we can say the tax is equal to the my house dot compute the tax. And let's say the tax rate is 10%. So let's break this down right here. And then let's, so that we can see what it actually computed. Print out the house, and then we'll print out the tax. Okay. So making the house, we're buying the house, we're computing the tax, and then we're going to print out the house, and then we're going to print out what the computed tax was. So the new thing we really added is right here. So let's talk about how this works. So if we look at our function compute tax, and it has this tax rate, if we look at it, again, it returns a float. Notice it's not changing any kind of internal value of the house, right? What I did not do, I didn't do something like that. I didn't change the value of the house. I did not change the color of the house. I didn't change if the door was open or closed. I did not change if the carpet was clean. All I did is I computed a value and I returned that value. And what am I computing? I'm just computing the tax, which is the value times the tax rate. And then I'm returning that value. So whenever I call this function, what comes back to me is whatever this value is. So that's why I have this variable is equal to whatever that return is. I returned this computed tax, and I'm going to save it in this variable. Let's watch this in action. If I run it, there you go. You can see my door is still open, the carpet's still dirty. The value of the house is this because that's what I bought it for. I'm computing this tax, and then I print the house in the tax. So the tax is 10.01. Is that, let's think about that. Is that right? So the tax is the value of the house times the tax rate, and that ends up being right. If we change the value to something different, let's say the value is 56.56, let's keep the tax rate the same. If I run this, see the value of the house is 56.56, and the tax is $5.66, if you round it, right? Well, if we change the tax, we can change the tax rate, say 25%. So if we run this, you can see, well, it gives us a higher amount of tax that we owe. So this right here is allowing us to compute what the amount of tax we owe is based on the value of the house and whatever tax rate that we want it to be. All right. So that is really all there is to the basics of Java class. Like I said, we've used, I see your hand up. I'll get to your question in a second. This example has been solely based on a house, but it can be any kind of object that you want it to be. For example, instead of a house, I'll do this really fast. Let's say we want a car. Let's think about the things that describe a car. We have the color of the car. We have the number of miles on the car. We can have the VIN number of the car. One more thing, we can have the gallons of gas in the car. Oh, there's one really important thing I left off the house, and I'll go back to it in a second after we do the car. So these are the things that describe a car. Remember, the variable types need to be private. For the functions, let's say we can drive the car this many miles. So if we do that, the number of miles goes up by how many miles you drove it. I'm not going to talk about these in great detail. I'm just showing how you can make another class that represents something different. It's not, obviously it's not just a house. It could be really anything. So you could drive it. You could, I don't know, fill up the tank with this many gallons of gas. So if you do that, then the gallons of gas go up by that much. That's just a quick example that you can make a class out of a car. Obviously the prime example was house. This is a car. Let me talk about the one really important thing that I forgot to mention with the house, and then I'll get your question. So we had all these functions here, to open the door, close the door, vacuum the carpet, buy, et cetera, et cetera. There's one more really important function that you should always have in a class, and it's called the constructor. The constructor is the piece of code that gets executed whenever you create a new house or a new of any kind of object. And it looks like this. Constructor should almost always be public. And it looks like this right here. So you have public, and then you have the name of the class. That's how you make a constructor. So inside of here is the code that will get executed whenever you make the class. So this is the best place to set like default values. What I mean by default values, it's values that exist whenever you make a new one. So if you look at all my variables here, I'm setting them all to be some kind of default initial value. So whenever I create a new house, this is going to be the default initial state of that house. I'm going to say the color is white, the door is closed, the carpet is clean, and the value of the house starts out to be 100. So let me show you the example with and without that. Let's delete all this stuff. Let's put a print there and a print there. So here will be my example using this. So like I said, this is the house. I'm going to comment it out, meaning whenever I do this, it's like this code isn't even there. It doesn't get executed at all. So let's see what happens if we don't have this constructor. So if we look in our main, here we're making the house and we're printing the house. We're going to buy it and then print it again. If we run it, you can see these default values here aren't really anything. You know, the value is 0, the color is null, meaning it doesn't have a color. And then after we buy it, you know, the value of the house changes because we bought it, but the color is still null, meaning it's blank. Well, let's add that constructor back in. Let's delete the comments, meaning this is now code that's going to get executed. So whenever we make a new house, this code will get ran automatically. So we're going to set the default values of what this house is. And where does that happen? I'm going to delete this car out of here because we don't need it anymore. Just a quick example. So if we look at our main here, here is where we create the new house, right? So whenever we make a new house, this is the code that's going to get executed. So if we saw before, the default values weren't really there, right? But now let's run it. Now that we have this constructor that's setting these default initial values, now let's run it to make sure that this gets executed. So we'll run it. And as you can see here, right after we make a house and we print it out, which is right here, it has those default values. It has the door open is false. Let's go to house so you can see it. So we said the color is white, and there enough, the color of the house is white. The is door open is false, right there it is. The carpet clean is true, right there it is. And the value of the house is 100, and there it is. And then of course, when we buy the house, you know, it prints this out, which the door, the door, the carpet, and the value has changed because we bought the house, but the color is still there. So even though we didn't do the house.paint, it did have an initial color, and that's because we set it in the constructor. And just like, you know, down here where we had, say, our compute tax took a parameter, our constructor can take a parameter as well. We can have the initial color and we can give it an initial value. So instead of just saying it's white, we can say it's equal to that initial color parameter. We can say the value is equal to the initial value parameter. But now, since this constructor is taking parameters, whenever we make a new house, we got to give it that information. Because if you try to compile it right now, it's going to fail, and it's going to give you some kind of description about why it failed. If we look here, it's because the constructor wants the initial color and it wants the initial value. So let's give it the initial color and the initial value. Let's run this. Let's delete out the buy. We're not too worried about that anymore. So we're just going to make a new house that's red with a value of 200. Let's run it. There you go. We print it out, and the door is closed. The carpet's clean. The value of the house is 200, and the color of the house is red. One more thing, and then I promise, Chris, I'll get to your question. So this is one house. Well, we can have more than one house. Let's make another house. Now, the name of the variable has to be different. You cannot have the same variable name twice. So let's just call this other house. And then we'll print out other house. So we're going to make one house. The name of the variable is my house. We're making a new one with the color red and the value of 200. We're going to print it out. Now we're going to make another house. We call it other house. And instead of red, let's make it green. Instead of 200, let's make it 150.15 as the initial value. And then we'll print out the other house. So now we've made two houses. One of them is this variable, my house. The other is this variable, other house. Let's run it. And there you go. There is my house printed out, with 200 in red. And here is the other house printed out, which is, this value and the color green. All right. That's all I have to cover for Java classes. Like I said, some of it may have been fast, but the video is being recorded. You'll be able to go back and review it at your leisure. And of course, you can always email me if you have any questions or anything like that, and I'll help you out. So Chris, I'll go ahead and get to your question. So what's your question?
Yeah, thanks, Daniel. When you created in the house class, when you created the tax calculation, I noticed you declared a tax variable within that.
Mm-hmm.
I was just wondering, what's the best practice? Because you can just return directly without having to create that tax variable, correct?
Yep, that's correct. What he's saying here is, we made this variable tax and we said it's equal to this, this math computation, and then we return the tax. You can kind of shorten that down to you can shorten it down to that right there. So what it's doing, you're going to return whatever this calculation ends up being. So these two things are, they're equivalent. There's no difference. My personal preference is I prefer this. But if you do this, if you do it directly like this, that'll be perfectly fine. You're not going to lose any kind of points or anything if you do it directly like that. The reason why I prefer this is because let's say that you want to do something else. Let's say the tax isn't just this. Let's say you give some kind of tax break. Let's say your tax is computed to be that, but then, you subtract off $100 for whatever reason. Maybe you did a check. What do we have here? The value of the house. All right. We're going to do an if statement in here. This is a mid-level Java class, so there is some assumption that you've had a basic level programming course, and so you're familiar with if statements and variables and stuff like that. So I'm going to use an if statement in here. So let's say your tax was whatever this, but if the value of your house is less than, say, 100, then we're going to say you don't owe any tax. So you can do multiple things like this, or we can say, if the computed tax is less than 5, then we're just going to say you don't owe anything. So what happens here? We're going to compute the tax rates. This is the normal tax rate. If that value ends up being less than 5, then we're just going to turn it to 0. So if the computed value is less than 5, we're going to say you don't owe anything. So as you can see here, it started to get a little bit more complicated than just, it got more complicated than just that. So that's why I made it as a separate variable so that I could then do other stuff with it if I needed to. So that's why I kind of prefer explicitly doing it like this and then returning the tax. But if you just do the return and then the computation directly, that's perfectly acceptable as well.
Okay. Yeah, thank you. I've got a few other questions too, but I think Tom's got his hand up, so I'll yield a second and come back to it.
Okay.
Okay, I'll just do it real quick. I think it's your IDE. I see when you're passing values in, you can put the value name : and then you're actually passing the variable afterward. And I've never seen or done that before. Is that something that's going to be expected
No, actually,
Okay,
if you try to type that in, you're going to get an error. This right here, where it's saying the initial color, that's my IDE trying to be helpful to me.
okay, that's
And,
what I thought.
and it's trying to, it's giving me a hint about what that parameter is. So if you try to do, let's see, house, another house, oops, house age equals new house. If you try to do, initial color, colon, orange, et cetera, right? That will be an error. It won't compile. It won't work. And that's because this is just a hint that my IDE is showing me. It's not something that you can actually type in and it work.
Okay, yeah, I just wanted to verify whether it's just something new or like that I haven't seen before, or if it was specifically like your IDE helper. Thank you.
Okay.
Okay. And can I ask a few more questions, Daniel?
Yep.
This one, it's going back to maybe the differences in the return types. But when I was trying to work through the homework, and particularly when you get to the point where we're creating sort of the find maximum class and the find average in the project class, the return type is object. And, I first started out by trying to just calculate the average, using operators plus and divide, and you obviously can't seem to be able to do that. And I don't exactly understand why. Is it just because it's the return type object within that method, or something different that I'm missing?
Okay, so no, that's a good question. So this will get a little bit into the homework. So I'll talk a little bit about the homework right now, and I hope this will be able to answer your question.
Okay.
So for your homework, you have to make a weight class, right? And you have to do some stuff with it. So what I'm going to do, let me bring up the instructions here on my screen. Make sure I get it right. I have it open somewhere. There, I have it open. Okay, so I'll start off by giving some advice for the homework, and then we'll do a little bit of an example with it. So, so you have this homework assignment, and really it's broken down, I think, pretty well into different steps that you can do. It kind of has like an overview description at the top, and then it has it broken down into, one, and it gives you a couple lines of text about this is what you need to do. And then it gives you number two, a couple lines of text. Number three, a couple lines of text. So what I recommend, and what I'll do for an example here is, whenever you see those, don't try to do everything at one time. Meaning, if you read the entire description of the homework and then you just try to do it all at one time, I think that's a little bit of a mistake. I think what you should do is read one line at a time and then implement in code what it's telling you to do. And so I'll start by doing a couple examples of that. Obviously, I won't do it all. So you can see kind of what I'm doing one line at a time. And then I will get to your question about, adding and subtracting and stuff like that. Okay. Thanks. So if we start at the top, so, we have the overview. I'm not going to read the overview. We're going to start right there where it talks about the weight class. So it's saying a weight class should have 3 private variables, 2 private methods, and 4 public methods. So that's what our class needs to have in it. So if you see here, we've made a weight class. So underneath variables, number 1, it says a private constant variable called ounces in a pound that defines the number of ounces in a pound. So it tells us exactly what to do. It says a private. Now, when it says constant, unfortunately in Java, there's not a word constant, but the way we do that is with what we call static final. That's a way that you can make a constant in Java. It tells you what to call it. It tells you call it ounces in a pound. Oops, I'm sorry. It needs to be, I think this needs to be an integer. So it tells you to make it private. This is telling you it's constant. It doesn't, the instruction doesn't tell you to make it an integer, but it tells you the value is 16, right? And 16 sure does sound like an integer to me, right? It's not 16.5. If it was 16.5, maybe that's a float. But if it's just 16, that sounds like an integer to me. So that's why I make it integer. So that right there, that's line 1 under variables. I'll do line 2, but then I won't do any more of the variables. I'll do a couple of the methods. So let's look at line 2. A private variable called pounds with data type of integer. Okay, so it says it's private. It says it's an integer. It's called pounds. There you go. That's line 2 underneath that variable section of the weight class. So what I did, I took that one single line, talking about this right here. This is line 2 in your instructions. I took that one line of text and I converted it to this right here. I haven't tried to do the whole weight class all at once. I took one single line of the description and made that into one single line of the code. There's a couple more for the variables. I'm not gonna do those. But let me get to, I'll do 2 lines under methods. And then of course I'll leave the rest up to you for your assignment. So let's look at line 1 under methods. It says a public parameterized constructor. So it tells us it's public. It tells us it's the constructor, which the constructor always has the same name as the class. It says it takes, actually, it shows you the constructor there, and it looks like this. Ounces, right? It shows you this is what the constructor looks like. And here you need to do the implementation, right? So double, when we see integer, that means it's an integer. Double is like a float. It's a decimal number, but it can be a lot more precise. So you can almost use a float and a double interchangeably, but just know that a double is a lot more precise than a float. But the trade-off of that is that it takes up more computer memory. So you kind of got to balance how much memory your program uses versus really how precise that you want it to be, which is the difference between a float and a double. But if the assignment says to use a double, you need to use a double. So this is the constructor. So it says you need to do the implementation of the constructor, right? So what do you need to do in here? Really, in here is where you need to set those default values. If we look back at our house where we had, this house constructor, this right here is a public parameterized constructor. It's public. This is the constructor because it's the same name as the class, and these are the parameters. And so what did we do in here? We set up the initial values of our variables, right? That's really the purpose of a constructor. So in our weight, we need to set the initial values of our parameters. So this one is pounds. Remember, you don't need to set this in the constructor. Why? Because we said it's a constant. Remember, static final just means it's a constant. And once you set, whenever you see the final, once you set that value, it can't be changed anymore. That's the idea of a constant that can't be changed. So we don't need to set it, but we do have this pounds. And so we set the value of the pounds, to whatever that parameter was. Here, we need to set some ounces to whatever this is. I don't have an ounces variable right here, but you do need to have one. That's part of the instructions. Remember, I'm not doing every line of the instruction, but one of the lines of the instructions tells you to make an ounces variable. So also here, need to set the ounces variable, right? So that's kind of what you need. That's what you need to do for the constructor. So the line tells you a public parameterized constructor. There's a public parameterized constructor, and it initializes the private variables. Well, there I have initialized the private variable. There's some more in here you're going to have to do, but that's line 1. Let's do line 2. Actually, we're not going to do line 2. Let's do one that's going to help answer his question. Boy, believe, boy, double weight, 2 ounces, normalize, less than, add to. Yep, let's do the add to. The add to will probably help. Not exactly your question, but you'll see how it will help. So if we go down to line 5 under the methods, let's look at line 5. So it says a public instance method called add to. Okay, so let's make a public instance method add to with a return type of void. So the return type is void. The name is add to, and it shows you what it should look like. It should take a weight and a weight, right? So this is line 5. So it says this method should accept a weight object as a parameter. That's what it's doing. It's a weight object as a parameter, and it should add the object's weight values to the initialized values. So our weight is really these pounds, and it is some ounces as well. So if we're going to add a weight to it, we can say this pounds is equal to the weight pounds. Also, whenever you end up doing the ounces, you can have this dot ounces is equal to the weight dot ounces. So what we've done here, we've taken this weight and added it. So this whole class is a weight itself. And we're saying we want to add to it this other weight. And we do that by adding up the pounds and by adding up the ounces. But I'm going to delete the ounces out of here so it'll actually compile. But you need to know that you need to implement these ounces in here that the homework is telling you to add up. All right. So now we'll be able to get your question about we need to do, I'm thinking a couple steps ahead here. We need to do one more of the methods in order to do the average and stuff that you're talking about. The other one we need to do is line 2. If we look at line 2, I'm giving away the house here. I'm doing more than I probably should, but you'll get a lot of help here on the first assignment. Let's look at line 2. So a private instance method called 2 ounces. Let me look. I'm just trying to read ahead to make sure I don't give away too much, but that I am able to answer your question. Find minimum, find maximum, find average. I just don't want to give away too much. Okay, this is how we'll do it. And actually, I do see one error in the assignment, which I will have fixed. So let's look at line 2, where it says a private instance method called 2 ounces. Actually, I want you to change that to public. And you'll see why, because we do need to use it. I will send out an email with this correction as well, so that you have it. So let's look at a public method, a return type of double. Its name is 2 ounces. The method has no parameters and should return the total number of ounces. So how do we take this weight and compute how many ounces are in it? Well, we have the pounds, right? But we have pounds, but we want to know how many ounces it is. This right here, this should compute the number of ounces, right? We're going to take the pounds times the ounces in a pound. But you need to remember, you're going to have some ounces in here too. Remember, you should have an ounces variable in here, but I'm not going to do it all. But for what we have so far, this will compute the ounces, right? How many pounds does it weigh? And then that's how many ounces are in a pound. So if it weighed 1 pound, this should return 16, right? Because there's 16 ounces a pound. If it was 2 pounds, it would return to us 32, right? All right. So let's go back to our main. let's delete out all of our house stuff. Let's make a weight. We'll call it weight 1. It's going to be a new weight. And what do we got to give it? We need to give it the pounds and ounces. Let's say it's 1 pound, 0 ounces. All right. Let's make a weight 2, a new weight. Let's make it 2 pounds and 0 ounces. I'm putting 0 ounces because I did not implement the ounces. You do need to implement the ounces in the weight class. Let's make one more. Weight 3 is equal to the new weight of 3 pounds and 0 ounces. Okay. So let's print out each of these. System.out.print weight 1, S1, weight 1, weight 2, weight 3. Let's run it. As you can see, remember, just like the house, it didn't print out something very useful. That's not very useful. Remember what you got to do. You got to make that two-string method. Let's just print out the number of pounds or something. Pounds. So now when we print it out, we'll get something useful. There we go. So now when we look at our main, we have weight 1, weight 2, weight 3. That's how much it weighs. We're going to print out each one, and you see each one is 1 pound. That's 2 pounds. That's 3 pounds. Okay. So how can we get the average of these? That's kind of the question that he asked. What you can't do, weight, say average, is equal to weight 1 plus weight 2 plus weight 3 divided by 3. You know, generally, mathematically, that's what you would do, right? You would add the 3 weights together, and then you would divide by 3. Mathematically thinking, that's how you would get the average, right? But, you know, I get the red squiggly here. Also, if I try to compile it, it's going to complain to me, right? It's saying, you know, bad operand types. It's a little confusing until you get used to it, but it's telling us that we can't use this plus sign with these weights. And why is that? Well, how do you add a weight? You know, if you're thinking as a person, then you forget about computers for a second. How do you add a weight? Well, you take whatever the value of the weight is, right? If a weight is 2, if a weight is 1, you add the values together, right? But this W1, it's not a value. It's something called weight. Weight is not a number value. Weight is a class, right? So that's not a number value. So you can't add these together like they're number values because they're not number values. But what we can do is, let's look back at our weight. Let's say we made this method here called add to, right? And what does it do? So we can take our weight and we can add another weight to it. So let's look here. So let's make an average. Let's make a new weight that starts off being 0. It doesn't weigh anything right now, right? This average does not weigh anything. But we can add to it another weight. Let's put some other prints in here. Put a print in between each one. Actually, instead of average, I'm going to call this sum. I don't want to do all the work for you, so I'll just show you how to add weight, how to get the sum of some weights. All right, so we're going to make a new weight. It's going to start off being nothing, no pounds, no ounces. We're going to add to it weight 1, and then we're going to print it out. Let's just run that. You see, so that's weight 1, weight 2, weight 3, and so far the sum is 1 because we've only added weight 1 to it. Well, let's add the other weights to it. Now, if we run it, the sum is 6 pounds. So right now, this sum, it is a weight, but it is the value of all the weights added together. And we did that with our add to method. And we had to make our add to method. Remember, this add to method is one of the things that your instructions tell you to make. So this is how we're adding the weights together. Here, we are using the addition sign, and that's because pounds is an integer, and a computer knows how to add numbers together. So we can just, when we do the add to method, it adds the pounds together. So that's how we can get the sum of the three weights. What you need to figure out how to do is, well, if I take this sum, I need to divide it by 3, right? To get the average. Well, just like you can't add a sum, because a sum is not a number itself. You can't subtract it. You can't multiply it. You can't divide it. You need to figure out, well, how do I get that into some kind of number, and that I can divide by 3? There's 2 ways you could do it. I'll verbally tell you what they are. I'm not going to do the code for you. So there's 2 ways you could do it. One is, just like we had an add to method here to add a weight, you could make another method, divide number, where you could say, give it a number that it would divide it by, right? And so what you could do then, you could say sum dot divide by 3. That's one way you could get the average, is by making your own method to do the divide. Another way you could do, so we have this, let's look at it. I do want to wrap this up here shortly. We have this 2 ounces method, right? So what I could do the sum, and say the average is equal to the sum, 2 ounces divided by 3. So it wants us to use doubles. There we go. That's another way you could get it. This would give you the average of all the ounces. Then, you may have to do some work to make sure, it's in pounds and ounces. But this is another way you could do it. Yeah, either way you choose, is fine with me. But the key here to remember is that you can't do plus, minus, multiplication, and division. You can't do that with actual class objects. You can only do that with raw numbers. And so, like I said, W1 plus W2 does not work. But W1 dot add to W2 will work. But why? Because we made this function to add them together.
Okay. And also, Daniel, thanks for that. It's very helpful. Sort of gets me pointed in a better direction. I was kind of following the instructions literally here, trying not to add methods, but is it okay to add methods even though you sort of specify a minimum number here?
Yes, you can absolutely add additional methods if you need them.
Okay.
And then the instructions will tell you at a minimum what you need to have. Okay. But you are perfectly free to add additional if you need them.
Got it. And then my other sort of final question here is that when it talks about the where did it go? It talks about the input, taking the input for the 3 weight classes. Where is it? Sorry. I think it's on the project methods here. And with the yeah, here it is. Find minimum, it says the method should accept 3 weight objects. And again, I'm maybe reading that literally, that you have to take a weight 1, a weight 2, as a weight 3 as a parameter into the find minimum function. Or can we solve that in other ways? Like coming out of the other class, find minimums, I would usually use some sort of loop or something like that. Are we limited to the 3, or can we solve it in different ways?
No, it's very important to follow the specification. So if the specifications say it wants those 3 weights, you need exactly those. I'll show you what it looks like, and then I'll take like 30 seconds to explain why the specifications are incredibly important.
Okay.
So it says, a private class method with a return type of weight.
Right.
And it's named find minimum, if I spell that right,
it says it should accept 3 weight objects. That means you need to have a weight 1, a weight 2, and a weight 3. In here, you need to do some work, and then you need to return the answer.
Right. Okay.
Right. And the answer has to be a weight because that's the return type here. So your function does need to look like this because that's what the specification tells you what you have to do.
Okay.
30 seconds about why the specification is important, and then we're going to try to wrap it up if there's no more questions. So this may be really short and easy, and you're the only person working on it. And, you know, it may not seem like a big of a deal if you don't make this exactly. But if you get a programming job out for some organization, you are not going to be the only programmer. You'll be on a team of tens of programmers, maybe 100 programmers. And instead of, you know, 20 lines of code, it'll be 20 or 200,000 lines of code. So whenever you're working for an organization, they'll segment the work and assign work to other individuals. And whenever the design is taking place, everyone else is expecting your functions to look a certain way. Anybody else who wants to use your code, according to the specifications, this is what your code is supposed to look like. If you do not follow that, then everyone else that is relying on your code to look a certain way, they will get an error. So for example, if you change, well, let's say you had 4 here instead of 3. The specification said 3, but you added on an extra one. If there is someone else in another part of the company making some kind of code and they want to use this function that you made, well, since you changed the way, since you deviated from the specification, their code is no longer going to work properly. So that's why it's incredibly important to follow the exact specification.
Okay, thank you.
All right. Any last question before we wrap this up? And like I did say, I'll try to get this video posted up a little bit later today, and you'll be able to review it at your leisure. Any other questions you may have? And if you can't think of any right now, by all means, email me. Email is the quickest way to get a response to me. You can email me for any question or any help really at any time.
Maybe just a very easy one, Daniel, which
Okay.
I hope's an easy, right? When you were setting the Boolean variable and you were setting it equal to true or false, if you wanted to compare that, do you have to use the is equal method?
No, you can just do, let's just say we do it right here. We can just say, if this door is door open, that's a short way. You can just say, is it open? If it's true, you know, it'll do whatever's inside the code.
Okay.
I like to see this, to be honest. Is that right? Oh, that's my IDE complaining that I can simplify it, but that's why it's funny color. Don't worry about the funny color. It's actually fine how it is. I like to see it like this. You know, this is door open equal to false, or is door equal true. I think this is more descriptive, but you can just have that right there for true, and that's fine.
Okay.
You don't need the, was it is equal or equal. Actually, I don't even think Boolean has the is equal. That's really only on strings.
Strings. Okay.
Yeah, which we can get to at a later point in the class. Yeah, but for Boolean values, that doesn't even exist.
Okay, got it. Thank you.
Okay.
Very helpful.
Any other questions before we start wrapping it up? Let me look at the chat. Nothing in the chat. All right, I'll stand by for like about 1 more minute if you think of anything. Otherwise, enjoy the rest of your Sunday. I will email out to the class list a link to the video later today when I get it posted.
Thanks, Daniel.